All right, let's jump right in. Welcome to today's Explainer, where we're going to unpack the absolute massive acceleration we've witnessed in AI video generation. We're tracking a really fascinating journey today, moving from those early, kind of weird experimental clips we all remember, all the way up to the absolute directorial control that defines the industry in 2026.
Right off the bat, to get a sense of the sheer economic stakes here, just think about this number, a 91% cost reduction. Honestly, this is exactly why enterprise adoption has absolutely exploded. We're talking about dropping traditional production costs from around $4,500 per minute all the way down to just $400. I mean, that is a categorical shift in how creative work is funded and executed.
So, here's our roadmap for today. 1. Evolution to cinematic director. 2. How AI video actually works. 3. The temporal consistency challenge. And 4. The 2026 production frontier.
Okay, Section 1, Evolution to Cinematic Director. Tracing the tech tree.
Think of this evolution kind of like a tech tree in a video game, right? We started out at Tier 1, the proof of concept era, where you'd type a text prompt and just cross your fingers, hoping the result vaguely resembled your idea. Then we added anchoring images in Tier 2, structural motion in Tier 3, and actual camera lenses in Tier 4. And now, in 2026, we're operating at Tier 5, the cinematic director. This is a multimodal architecture where developers and creators have genuine directorial control over multi-shot scenes with fully synchronized audio. It's wild.
And this right here is exactly why 73% of Fortune 500 companies have deeply integrated AI video into their infrastructure. I mean, compressing 13 days of traditional production into just 27 minutes, that enables rapid, iterative testing at a scale that was physically impossible just a few years ago. You can literally test 10 variations of a campaign on a Monday and have the winner scaled globally by Friday.
To understand how we got that fast, we really have to look at the architecture. Based on a comprehensive paper from the ISMAIR Academy, if we compare older models against the current state of the art, it tells a clear story. Back in the mid-2010s, generative adversarial networks, or GANs, which essentially learned by pitting two AI models against each other, really struggled with extended narrative coherence. They basically had amnesia. They just couldn't remember what happened 3 seconds prior. Modern space-time transformers solve this by treating video like language. They segment the frames into manageable patches and model the intricate interactions over time. Moving on to Section 2, how AI video actually works, under the hood.
You can think of this pipeline almost like a traditional film crew working at lightning speed. In Step 1, your text prompt is the shot list, and the language model acts as the storyboard artist, picking out verbs and camera angles. Then, Step 2, the diffusion model generates an initial frame from pure static noise. And finally, Step 3, the temporal layers step in. These function as the motion brain, making sure that the elements in frame 1 logically flow right into frame 2. So your actor doesn't, suddenly turn into a car mid-stride.
We can visually demystify the magic a bit by looking at Google Lumiere's space-time U-Net architecture. Instead of rendering frame 1, then frame 2, and so on, which practically invites errors, this system is designed to generate the entire temporal duration of a video in a single pass. It processes multiple space and timescales completely simultaneously. Which brings us to Section 3, the Temporal Consistency Challenge. So this is the absolute boss-level challenge we've got to tackle next. Temporal consistency. Generating a single photorealistic image? Yeah, that's a solved problem. But temporal consistency requires the model to maintain global coherence across the dimension of time. Every single pixel needs to remember exactly where it was a fraction of a second ago. It's computationally expensive, incredibly difficult, and honestly, it's the main reason those early AI videos of people eating spaghetti used to look like terrifying fever dreams. But hey, the engineering is caught up. Modern models like LTX 2.3 address these specific temporal issues head-on. If you have flickering, they adjust spatiotemporal guidance. Warbling? That's solved using retake pipelines. If a character's face starts changing, which is known as identity drift, they lock it in using character LoRa's or IC LoRa pose control, acting like a digital blueprint for a specific face. They use 3D rotary position encoding to jointly track where an object is in space and where it is in time, making sure your subject's fur pattern or facial structure remains flawlessly intact from frame to frame. It's a real game changer. And that leads us to our final section, Part 4, the 2026 Production Frontier. The landscape today is just overwhelming in its capabilities. APIs now accept strict cinematography data. You aren't just typing a prompt anymore. You're literally passing commands like 35mm lens or low-angle tracking shot.
You can lock a character's aesthetic, build multi-scene narrative logic using scene graphs, and sync the audio perfectly. It allows creators to command a scene that looks virtually indistinguishable from a high-budget Hollywood shoot, entirely through code.
And what's really amazing is this immense power isn't just locked behind massive corporate paywalls anymore. We've officially entered the Omni era. Open-source models like HappyHorse 1.0 and LTX2 are trained simultaneously on video, text, and audio. They're bringing 60 frames per second cinematic-grade rendering right to local GPUs. They are making high-fidelity motion dynamics accessible to independent creators everywhere. The democratization of this tech is fully underway. So as you digest this totally incredible evolution from glitchy text to video all the way to absolute cinematic mastery, I really want to leave you with this provocative thought. If the barrier to technical execution has completely vanished, if the machine can flawlessly execute any camera angle, any lighting setup, and any motion, what is the true value of human taste, timing, and judgment? In a world where absolutely anyone can point the camera, deciding exactly where to point it becomes everything. Thanks for joining me on this explainer, and keep exploring.